Greetings and salutations. This is my presentation on residential electric. We're going to concentrate on and emphasize on AWG and wire connectors. I'll explain what AWG is later on. Here are a few things that we will cover in this presentation. We will cover other concepts along the way, like resistance and types of materials. Those are only covered as to assistance with learning the basics of what is listed. Alright, let's start with the basics of residential electric. We live our lives around electricity, and we cannot imagine our lives without it. But what is it, and how does it work? If we were to remove that decorative light panel on the front, we would be able to see the wires going into the actual duplex. As you can see in the bottom right-hand corner, those are the wires that are most likely going to be seen. So, at the top left, you will see a duplex outlet with 3 openings for each receptacle. Each hole represents one part of how the electricity functions. The top left port is the largest opening, and that is reserved for the neutral or white cord. The smaller opening next to it, that is always going to be your hot opening. That's going to be your black cord or positive. And at the bottom you have a ground. That is usually green. It's not going to be green on the end of a plug though. It's most likely the only one that has a round tube-like structure. So why are the holes different sizes? Well, this is done because even though the neutral wire shouldn't have voltage, it actually does. It has a minimum voltage. This is done to overcome the resistance of the wire and complete the electrical circuit. In residential electric, we usually run copper, but sometimes aluminum is used also. In the previous slide, we discussed which opening did what on the receptacle. Here, we discuss what material should be used and why. So we mentioned that neutral in the previous slide had minimal voltage to overcome resistance and complete the circuit. Let's talk about resistance real quick. As the electricity flows through the wiring, it runs into the resistance. Let's think of this as like flowing water in a river. The more stones in the river, the amount of volume of water flowing is reduced, and the water must move around the stones. With electricity, it's moving through the wire and having to move around the impurities in the metal. Now, when electricity moves, it generates heat within the metal. So why does this matter to the metal? Now, aluminum is cheaper and will work for electrical wiring, but aluminum, when it generates heat due to resistance, will expand. If you look closely to the image on the bottom right-hand corner, you will see the wire is wrapped around the screws. Over time, that wire, if it's aluminum, will expand and contract tens of thousands of times, slowly loosening the screws. Eventually, this will cause the connection to separate, causing an electrical arc. This can lead to electrical fires. Now, I know this can be kind of scary. Don't be afraid to buy a house if it has aluminum wiring. It just means it requires maintenance. But a lot of people don't do the maintenance, so take that as you will. Copper is going to be better than aluminum in safety, but what else is it good for? Copper also is more flexible and able to bend easier, but also has a higher tensile strength than aluminum, up to 40% higher. This means it's less likely to break, and this means less likely to cause an arc and create a fire. If you have ever done wiring, you know that we are pulling it and bending it all over to get it into places. In order to determine the size of the wire you should use, we need to refer to the AWG, or the American Wire Gauge. There is an inverse linear proportional relationship between the cross-section of the wire and the amount of resistance you may encounter. I know that's confusing. So what does that mean? It means the bigger the cable, the less resistance you have. If your resistance goes down, you lose less voltage over a distance. This increases your amount of voltage availability at the end of the wire. Basically, this means you will have more power available. So this is kind of very important, especially if you're going long distances. So why is this safer? Well, if resistance makes heat, that heat will affect the plastic coating around the wire. It won't happen right away, but it will happen eventually. When it does happen, this is called thermal degradation. Put simply, heat breaks down the chemical bonds in materials. In this case, it increases the chances of arcing and creating fires. How do we know what size to use? Well, that's where the AWG comes in. So they do a little interesting thing by scaling the wire from the smallest wire size with the biggest number, starting at 40, then 1, and then 0, then double 0, then triple 0, and then quad 0. If you increase the wire size by 1, you increase the diameter by 1.123. So the smallest conductor permitted in the building electrical installations is for number 14. This will carry about 15 amperes safely and is commonly used for switches and circuit wiring. Number 12 wiring carries about 20 amperes. This is what's preferred for home duplex and lighting circuits. Other examples of this would be water heater running number 10 gauge wire with a large draw power like a range stove. You'd want maybe number 6. So what size do you need? That is determined by your amperage or how much energy an item needs. So 14 gauge would equal 15 amperes, 12 gauge would equal 20 amperes, 10 gauge would equal 30 amperes, 8 gauge equal 40 amperes, and 6 gauge would equal 50 amperes. So how do we know what kind of wire to use? Well, the wire tells us. If you know how to read it. 14-2G means there are 2 insulated wires, and those wires are size 14 gauge. The W/G means it has a ground wire also, so that would have 3 wires inside of it, where the ones that say 14-2G would only have 2 wires inside of it. The above wire is type NM, or non-metallic sheath wire, or Romex, and this is the most common type of wire you will see. So now that we know what wire we need and why, let's focus on the connectors. This is where your duplex outlet will sit or your light switch. Here we peel back the protective coating of the Romex to expose the length of the wire. On the right, you will see 2 types of connections. One is a screw connection, where the wire is wrapped around the screw and the head is then tightened down to secure it. The other is a push-in connection, where the wire is just pushed into a slot. Now on the left, you can also see connectors that are mounting the Romex to the outside of the box and securing it, stopping it from moving around and causing damage. So here are some other types of connectors. I have always heard these referred to as wire nuts. Now this is just a few of them. These range in thousands of sizes. And usually, depending on the diameter of your wire, there's a wire nut that's associated with that. You basically have to remove the protective sheathing around the wire in order to expose the metal. That's the bottom left-hand corner picture. After that, take one of the electrical nuts and screw it onto the other 2 wires, making sure the lengths are equal. Inside the wire nut, there is a spiral shape within that makes the 2 wires wrap around each other. I personally put electrical tape around the 2 ends also to secure them in place. When you're wrapping the wires like this, you want as much surface-to-surface connection as possible in order to obviously stop arcing or having thermal degradation. You may sometimes see the braided copper wiring on the top picture. This is done to keep the bigger diameter and to also keep the flexibility of the wire. But in the instance above, that form of connector that is being used there for the braided copper wire, this is used when you are going to have a lot of movement or vibrations. That concludes this presentation, and I hope you learned something from it that may benefit you. I know when I was younger, I thought rewiring a house would be extremely complicated, but just like anything, if you just start looking into it and taking your time, you will get the hang of it. I will have some questions after the presentation to test your knowledge. Thank you and have a great day.